Hi everyone. After completing the second stage, the absorption stage, onto activated carbon, which we explained in the previous video of this series, it involves passing the gold purine solution, usually composed of gold cyanide, through tanks or columns filled with activated carbon. The carbon absorbs the gold particles from the solution, resulting in gold accumulating on its surface. The gold purine solution consists of sodium cyanide and NaCN and water, with a cyanide concentration ranging between 0.02% to 0.05%. Sodium hydroxide and NaOH is added to maintain the alkalinity of the solution at a pH between 10 and 11. The carbon to solution ratio is approximately 10 to 20 grams of carbon per liter of solution. After this stage, we move on to the extraction or stripping stage, which involves gold elution. This process involves subjecting the carbon to removal process or stripping process using a hot alkaline solution, sodium hydroxide and cyanide, to release the gold back into the solution. The alkaline solution composed of NaOH at a concentration of 1% to 2% and sodium cyanide and NaCN at a concentration of 0.1% to 0.5%. The solution is heated to a temperature between 120 degrees and 150 degrees. Duration of this process, it takes between 8 to 14 hours depending on the system efficiency and carbon size. Electro-winning cell. This stage involves using an electro-winning cell to precipitate the gold from the gold purine solution by applying an electric current, causing gold to deposit onto the cathode. Electro-winning cell details. Electric current ranges between 150 to 300 amperes with a voltage of 2.5 to 3.5 volts. The solution used, the gold purine alkaline, is continuously circulated. Cathode and anode. The cathode is made of stainless steel or gold-plated tin. The anode is made of lead or titanium coated with ruthenium. I assure you this video will be very exciting. Please stay tuned and subscribe to the channel. Let's begin the stripping process step by step. Step 1. Carbon-filled column. After emptying the saturated carbon from the columns, it's loaded into the extraction column with a capacity of 500 kilograms. Step 2. Extraction solution in the tank or mixture. Prepare the extraction solution in the dedicated tank or mixture. The solution consists of pure water filling the tank, amounting to 1.61 cubic meter. Add the solution materials: 5% sodium hydroxide NaOH when used alone. Alternatively, the commonly followed method is to add 3% sodium hydroxide and 0.1% sodium cyanide NaCN, meaning 35 kilograms of NaOH and 1.5 kilograms of NaCN. Turn on the fan and heater until the temperature reaches 95 degrees in cold weather or 60 degrees to 70 degrees in warm weather, as seen in the video. The mixture consists of a motor that spins the fan to mix the previously mentioned materials, a heater to raise the temperature, and a metal pipe through which the solution is transferred to the electro-winning cell. The mixture is usually located on an elevated platform or upper floor, as you see in the video. There is also a water tank with a pump and a hoses to supply water to the smelting room and supply water to the mixture. Okay, very good. Step number 3, emptied solution from large column. The carbon solution in the large column is emptied by applying air pressure through the pipe from the filter towards the electro-winning cell, ensuring the valve before the filter is open. Once the compressor reaches 0.2 megapascals, open the lower valve in the large column to empty the carbon solution. Repeating the process 2 or 3 times to ensure the carbon is completely dry. Very good. Step number 4, directed solution from upper tank towards the electro-winning cell. This step is linked to step number 2, where the solution is directed to the extraction circuit consisting of the floor, heater, and column and cell, through the valve from the upper tank feeding the pump. The solution flow is regulated at a rate of 2 to 4 meters per hour, as shown by the flow meter device. The valve controls the solution entering the cell through the metal pipe, which allows the solution to flow into the cell's last tank, gradually filling it and flowing between the cathode and anode. The solution level is monitored by a gauge with a magnetic ball that rises with the solution level, as you've seen in this video. This coming from the upper tank and enter to the cell. This is a feeding valve. The solution gradually filling our plates. This is a gauge with magnetic pole that rises with the solution level. Step number 5. Solution flow from electro-winning cell towards the heater. Close the upper valve from the mixture and using the DC control panel. Start pump number 1 as you see in this video. Start pump number 1 to draw the solution from inside the cell. Then open the lower valve existing in the cell, allowing the pump to pull out the solution. The solution then flows through the metal pipe to the heater. A bypass valve collects periodic samples to check the remaining gold concentration. Before entering the heater, a digital meter records the amount of solution entering. Once the heater fills, it activates, heating the solution to 100 degrees as read on the control panel. Step number 6. Voltage and current of electro-winning cell. Once the temperature reaches 100 degrees, the DC system of the electro-winning cell is turned on. Setting the voltage between 3 to 4 volts and monitoring the current, which should range between 200 to 400 amperes. Step number 7. Solution flows into carbon columns, then passes through the filter, then back into electro-winning cell. As the solution flows into the carbon-filled columns, it fills and then passes through the filter located on the upper floor. Once the filter fills, the solution descends through a metal pipe back into the electro-winning cell. A safety valve releases excess pressure and gauge measures the pressure. The upper spout empties the carbon into the large column, while excess water is drained, as you see in this video. You see the solution flows from the carbon column to this is the filter, and then go back to the cell by this pipe. This for release pressure, and this hose that hose for excess water. Step number 8, gold concentration and incoming and outgoing solution samples. After 30 minutes to an hour of extraction or stripping process, samples of the incoming and outgoing solutions from the cell are taken to confirm that gold is being deposited onto the cathode. Samples are taken periodically to monitor the deposition process. The atomic absorption device is used to measure the gold concentration in the samples. Step number 9, pressure and temperature monitored. Pressure and temperature must be monitored after 3 to 4 hours. The pressure reaches 0.5 megapascals and the temperature reaches 150 degrees. When the pressure reaches 0.6 megapascals, it's manually released through a valve into the upper mixing tank. If not manually released, it is done automatically. The temperature must not exceed 130 degrees. If it does, the heater is turned off until it cools down, then restart it, as you see in this video. Release our pressure by this pipe going into the tank or mixture. Step number 10, stop stripping process based on the atomic absorption device reading. After 10 or 11 hours, the extraction process is typically completed. Samples from the cells incoming and outgoing solutions are taken to monitor the gold concentration. The process is stopped based on these readings. Step number 11. Once extraction is completed, pressure and solution are released gradually through release valves. The carbon in the large column is emptied as shown in the video. The electro-winning cell is left to cool. Step number 12. After opening the cell, the cathode plates are removed and washed in a tub. The recovered sample from the inner tank of the cell is then dried. Step number 13. This is the last step. Dry the sample and smelting room. After drying the sample is waited to determine the amount of chemical added in the smelting room. In the next video, we will enter the smelting room together and explain all the steps until the gold bar is obtained. I hope you enjoyed this video and found it informative. Most views of the channel's content are not subscribed, so please subscribe to continue this journey with us. Thank you for watching. Stay safe and goodbye.